In this video, I'm going to be continuing the RL from scratch in Python series where we implement a reinforcement learning agent in Python. So for this video, I'm just going to be creating the agent class itself, but we're going to actually integrate it into our environment in the next video. So to create the agent, first I'm just going to create a new file called agent.py and I'm going to open it. Here I'm going to say class agent, and then in the init it will take a position. That will be a vector. We have to import the vector 0, or it'll be 0 0 0. Then it will take an axis. That will be another vector of 1 0 0, and then it'll take a size. It'll just be all ones, and then finally it will take a color. Will be color dot red. We have to import these. So over here at the top, I'll say from vpython import vector, and we're also going to import color. And then after that, I'm just going to assign all of these to self dot pos equals pos, self dot axis equals axis, and so on for all of them. And then we'll also define the body, so self dot body, because we need eyes so that we can tell which way the agent is facing. So we're going to define the body here, which will be a box. We have to again import this. The position is position, axis is axis, size is size, and the color is the self dot color. And then again over here we have to import that. So now if we run this, since in the next video I'm going to, in this environment.py file, I'm going to be like from agent import the agent class. So over here I'm actually going to say if underscore underscore name equal underscore underscore main, then I'm going to run this. Otherwise we're not going to run it, because when you import it, it is going to run the script. So this will just make sure if we're importing it, it won't run this, but if we're running the file itself, then it will run whatever code block we put in here. So in here we'll just say agent equals agent class, and since they have default parameters, I'm not going to add anything. And then we have to create a while true loop, because if the Python script terminates, then so will if the Python script terminates, so will we Python. So I'm going to say Python agent.py. And you can see we have a red cube here. I can move around and do whatever. I'm just going to set the shininess to 0 so that it doesn't reflect as much light and it looks a bit better. And then since we want eyes, I'm going to create an eye class over here. So I'm going to say class eye. And then in the init function, it's just going to take a center and it's going to take the radius. And then self dot center will be center. Self dot or before that we can also say, because we're not going to change the size of the eyes, we're not going to change the size, we're just going to be moving them. So we don't need to say self dot radius equals radius. Instead we're going to define a forward vector. That will be a vector of 0 0 1, and then we'll say the self dot white, which is just the white part of the eye. That will be a cylinder, and we have to import a cylinder again. The position will be position, or no, self dot center. The axis is forward, and then we'll multiply that by the radius times 0.1, just like that. And then we'll say the radius equals radius, and then the color will be color dot white. And then self dot black will be a cylinder. The position is self dot center. But we will also add the forward vector, because if we have the white and black on the same center, then they will be fighting for who gets drawn on top of who. So we want the black to be a bit forward. So we'll add forward times radius times 0.05, just so that's a bit more forward. And then the axis will be forward. We'll multiply that by the radius, and we'll multiply that by 0.08. And then the radius is radius, and the color is color dot black. And of course, we have to import all those things up here. So that should be all for now. And then over here in the agent class, let's define an offset I offset x. So in the x direction, that will just be size dot x, and we will multiply that by 0.22 because I found that looks proper. And then I offset y will be size dot y times 0.18. You can obviously change this to whatever you want. And then the I right, basically the right side of the agent, because we want to start from there and work our way backwards, so not backwards, to the left. That will just be the minimum size dot x size dot y, and we'll multiply that by 0.12. And then we'll again define a forward vector like this. That will be a vector of 0 0, and then size dot z divided by 2, and we'll add 0.02. And then finally we'll say self dot left I. That will be an I class, or we're just creating the object here. And then it'll be a position plus the forward vector plus a vector of, it'll be minus I offset x, I offset y, and then in the z direction it will be just 0. And then the radius will be I r. Oh yeah, I forgot. This is not the I, right? This is the radius of the I. And then we're going to define the self dot right I. That'll be an I instance. We'll say position plus forward plus just the same vector basically, but instead of minus offset x, it'll just be offset x. And then we'll say again I underscore r. So now this should produce, or it should look like an I. And okay, we haven't closed this yet. Yeah. Oh, okay. So we have to do this here. I comma I underscore r. So now, so you can see here we have two i's, but the black is overlapping with the white. So we'll say radius over here in the I class, we'll say self dot black. In the radius, we'll say radius times zero 0.5, so that it's smaller than the white part. Yes, so now we have I, so we can see which way it's pointing. But now if I were to say So, but you'll notice instead of pass over here, if I say self or if I say agent dot position dot x plus equals like 0.01 every frame. So this will just move the agent. It won't move its eyes. We want to move the eyes with it. Or yeah, and also if you do this, it won't. You can't see anything because over here from VPython, you also have to import rate, and then in the while true loop you have to say rate 60. So that's just 60 f. Where it's going to try to run at 60 fps. Even if it can go higher, it'll try to run at 60 fps. Also, we can't just say pos.x. We also have to say body.x or body.pos.x. Now the body will move, but the eyes aren't going to move. Yeah, and we want the eyes to move with it. So instead of doing that, what we're going to do is over here we're going to add a def update function where it's just going to update the agent. In here we'll say self dot body dot post equals self dot post, and we'll also self dot body dot axis will be self dot axis. That way we can just instead of doing body dot position, we can just do agent dot position dot x. This will do the exact same thing, or maybe not. Oh yeah, we have to obviously call the update function. So agent dot update. We have to call the update method obviously. So now this will do the same thing. The body will move, but not the eyes. Yeah. So instead of that, we want the eyes also to move. We're also going to say the delta, or instead of that, we'll say over here self dot eye offset and self dot eye offset y. And then we also have to say here self dot and then self dot like this. So this should again do the same thing as before. Yeah, but this time what we can do is we can move everything. So we can also move the eyes. So we can say self dot left eye dot center. That will just be self dot position, and then we'll again add forward. We just copy this basically. So we just copy this and it will like this, and then we can just make this proper. And then oh yeah, we also have to define forward. So instead of that, we can over here we can say forward equals vector 0 0 size dot z divided by 2 plus 0.02, or we have to say self dot size. So now this will move the left eye, but we also need to be able to move the right eye. So I'll say python agent.py. This should technically move the left eye, or maybe not for some reason. Oh yeah, we have to make an update here also because it's just the init. So we'll say def update. We'll create an update method, and all we're going to do is just we're going to say self dot white dot goes yeah self dot white dot position will be self dot center, and then self dot black dot position equals self dot center, and then we obviously have to call that here. So after this we'll say self dot left eye dot update. So we'll call the update method. So this should move the eye, Yeah, you can see the left eye is moving, and for some reason the black part is not showing properly. We'll fix that. First we'll do the exact same thing for the right eye. So we'll just copy this and paste it here. No, we have to paste it here. And then we, instead of left eye, we'll say right eye. And then instead of again here left eye, we'll say right eye. And we also have to change this minus sign. So now if we call the update, and right now it should move the eyes as well. But for some reason you're seeing that the black part of the eye is not showing. And that is because over here we said center plus whatever this is. But we also have to do that over here because otherwise, like I told you, since they'll both be fighting for who gets drawn on top of who. So we have to also add forward times the self dot, or actually we do have to define the radius, which is self dot radius equals radius, and then we'll say forward equals vector 0 0 1, and then we'll say at the end here radius times 0.05, just like what we did here, but it'll be self dot radius. So now this should update the black eye, and we should be seeing both of them moving along with the agent, but we still don't. Yeah, that is because forward I accidentally put another 0 here. We have to put a 1. So now you can see the eyes are moving along with the agent. I zoomed out too far. Uh, yeah. So now let's try to turn the agent. So we'll say instead of this, we'll say agent dot axis dot x will say plus equals zero point 0.5. So again we have to do that in the update function. So body dot axis equals self dot axis, that is correct. But we also have to do that for the eyes, because right now the body will turn, or apparently not. So actually instead of doing this, we can actually just say dot rotate, and we'll say the angle will be, let's say, zero point 0.5, and the axis will be a vector of, let's say, 0 1 0. So this should rotate it along the y direction, or not. Yeah, we can't just say this. We have to say agent dot axis equals agent dot axis dot rotate, because it doesn't modify in place. It will return a new vector. Yeah, so you can see the agent is moving, but the eyes are the same. I'll actually just set this back to a point 1. So this will rotate slower, but we still need the eyes to rotate. Yeah, so the eyes are in place. So what we'll do is over here, we'll also say, we'll create a method called def rotate, so we can just rotate everything at once. We'll take an argument which is the angle, and we'll also take an argument which is the axis that we want to rotate about. And also up here, from, we'll also import another statement. From math, we're going to import radians. And then here we're going to say angle equals radians angle. Yeah, so we're the rotate in the axis dot rotate, the vector dot rotate method, the angle takes radians as a parameter. So instead of that, in our rotate method, we want to pass degrees as the parameter, which is why we'll say angle equals radians angle. So angle is in degrees, and we'll just convert that to radians. And then we'll just say self dot axis will be self dot axis dot we'll rotate it, and then just basically it's the exact same thing. Angle equals angle, and the axis is axis. So now this should do the same thing that we had before, but instead we can just say agent dot rotate, and then we'll say the angle is like some, let's say 20 degrees, and the axis will be 0 1 0. So we're rotating it about the y-axis. So we'll say python agent.py, and we get an error for some reason, which is, oh yeah, we have to make this a vector because I made it a tuple, but we have to actually pass a vector. So now this should run. Yeah, you can see we have it rotating again way too fast. So I'm just going to slow that down again. I'm going to say 1 degree. But we also, again, we want the eyes to rotate. In the update function, in the update method for our agent, instead of saying that, we'll say the forward equals self dot axis dot normalize. So we'll normalize it, and we'll also multiply that by, we'll create a tuple here, or just open some brackets, and we'll say self dot size. So the size dot z, like this, and we'll divide that by 2, and we'll also multiply by 0.02. So that will not move the eyes, but it will just recalculate the forward vector. So yeah, we actually have to move the eyes. We'll have to also say we'll take a forward vector here. In the update, we'll take a forward vector, and over here we'll say self dot white, or yeah, just basically we'll just do this. Instead of plus forward, we'll say forward dot north. So we'll normalize it. And we have to pass it, actually. I forgot to pass it. So over here, when we call update, we have to pass forward. So this should rotate the eyes with the agent. But for some reason, we're not seeing the eyes. The eyes are inside here for some reason. Okay, so over here I forgot to remove this line. That's why they appear in the center. So now this should rotate the eyes with the cube, but we still don't see it. And yeah, they're still inside. The eyes are still inside the cube. Over here, I forgot to do the instead of multiplication, it's actually addition. So we have the eyes, but they're on that side for some reason. For some reason, they're always pointing towards us. We want it to stay with the cube. So to make the eyes actually stay with the cube, over here we'll say forward, yeah, we'll say forward. In the eyes update method, we'll say forward equals forward dot norm. So we'll normalize it. And then we'll also set in the update, we'll also set the axis. So self dot white dot axis, that will be forward, and we'll multiply that by self, we'll open some brackets, self dot radius times 0.1, and then the self dot black dot axis will also be forward times self dot radius times 0.08. And we also have to do one more thing in the update of our agent class. No, actually, that should be all. So now if we run this, the eye should stay with the cube, but they don't, and we're still seeing them inside, but at least it's rotating. So you can see the one eye we have here that's rotating with the cube. So to actually make it look proper in the update method of our agent, while setting the left eye dot center, so I'll actually add some blank lines so you can actually tell properly. So while setting the left eye dot center, instead of all this, I'm just going to delete all that and I'm going to say self dot position, and then we'll add to that the forward vector. We'll subtract the side, multiply by the self dot I offset x, and of course over here we have to do self dot side, and no, not self dot side, we have to define side actually, and we'll add up to that. We have to also define up, and we'll multiply by I underscore, or we'll multiply by self dot I offset x, or y, it's y. And then up here we'll define, after defining forward, we'll say up equals a vector 0 1 0, and then the side will be a forward, you have to spell it properly. For side is forward dot the cross, so, and the cross is the cross product up, and we'll normalize that, so dot norm. And then again we'll say up equals side dot cross, so take the cross product forward and dot normalize, like this. So now the left eye should be proper, or it should at least spin with the cube. Yeah, so the left eye is spinning with the cube, but the right eye is not so much. So again, I'm going to do the same thing here. I'm just going to delete everything after here. We'll say self dot position, and we'll add forward, and this time we'll add side, and then we'll multiply this by the self dot I offset x, and basically the same thing, but instead of minus side, it's plus side. So actually the eyes are appearing on the other side of the cube, which is why, yeah. So now the eyes are actually rotating and moving with the cube. We can test the movement also. So we'll say agents dot position dot x plus equals 0.01. So it will move the agent and it will also rotate the agent. So yeah, you can see it's moving and it's also rotating, and the eyes are staying with the agent, they're not going anywhere. So that's it for this video. In the next video, I will be integrating the agent class into our environment class. But if you like this video, I have a channel with my friend. I'll pop it up somewhere here. You should probably go watch that. So far, only I posted. He will be posting soon. And that's it for this video. Okay, bye.